Hello everyone, and welcome to Global AI Bootcamp 2024. In today's session, we'll be talking about vector embeddings with Azure OpenAI versus open source models. I am Patricia Rodríguez Vaquero, data engineer at MyCloudDoor. And moving on with today's agenda, basically we will be introducing some key concepts in order to build a foundational knowledge and to be able to understand the following topics that we will be covering later on during the slides. These concepts are vector databases, tokens and tokenization, chunking strategies, text vectorization, and we will be also seeing a more practical case study. We will be able to configure a vector database, in this case Azure AI Search. We'll be also creating the index, populating or doing the data ingestion process in order to upload all of our data into Azure AI Search, and we will be performing some vector search queries in order to retrieve information, right? Moving on with the first concept, vector databases. Basically, vector database stores data as high-dimensional vectors, which are mathematical representations of features or attributes. And this allows fast and accurate similarity search and retrieval based on vector distance or similarity. In our case, we will be using the cosine similarity, that is the metric that OpenAI recommend us, okay? Now, there are different vector databases, such as the ones that Azure provide or some other open source that you can also use in order to store your data. Within these Azure vector databases, we have Azure Data Explorer, Azure SQL, Azure Cosmos DB, Azure AI Search, that is the one that we will actually be using, and some other open source databases, such as Milvus, FAIS, Quadrant, Chroma, and so on. Now, the second concept that we will be discussing and we will be explaining is tokens and tokenization. Here, and as we can see in this image, is a really powerful and useful visualizer tool that allows us to enter a text, a sentence, in this case, which Mercedes-Benz model is the safest one, and you are getting as an output several things, such as the number of characters that this sentence contains, which is 48, or the number of tokens, which is 10. So basically here we are seeing that this sentence contains 10 tokens, okay, or is equivalent of 10 tokens. Tokens here are just sequences of textual characters that at the end large language models convert into numeric representations, okay, and the process of converting this raw text into this series of tokens is called tokenization. These tokens can be words, subwords, even characters. Here depends on the tokenization strategy that you will be using. This concept is really important because at the end of the day, text generation and embedding models process text in these chunks that are called tokens. Okay, token is the metric that all of these models will be using in order to compute basically how much information they are allowed to compute. Here also, as a rule of thumb, one token is approximately 4 characters or 0.75 words for English text. And so here, just as an example, there are different embedding models that we will be also explaining in the following slides, all of them from Azure OpenAI API, and we can see here the different prices that all of them have, okay? And specifically for this text embedding 3 small model, the estimated price to embed our documents is the following one, $0.0005. And here there is also a table that we can see the ID field, the title field, the text field, and also here it was the number of tokens that all of these texts contain, okay? Now, the next concept, chunking strategies. Here we have two different images that allow us to understand the concept, and I am going to basically explain it. And we have a large document, okay, and we need to divide it into smaller manageable pieces, so-called chunks, and then we can, for example, pass all of these different small pieces of text into large language models and create individual summaries, and at the end combine them as a one global summary that you will be getting as an output. Why this concept is important? It's important because we need to meet the input size constraint of these embedding models. That's why we are dividing a really huge or large documents into these smaller pieces, okay? And basically here, this is a super interesting and also useful visualizer tool that allow us, again, we enter a text, we need to select the text splitter method that we will be using. In this case, is this recursive character text splitter strategy using the LangChain framework. And here we need also to select the chunk size, in this case 200, and we are outputting, we are getting some results, such as the number of total characters, which is 686, the number of chunks, which is 4, and also the average chunk size, which is 171.5. Here we can see visually how our text has been divided into these chunks, basically, okay? Let's also here put the emphasis that we have these different text splitter methods, but for our case study, we'll be doing a manual chunking. Okay, we will be defining a function with Python that will allow us to create these chunks. Now the next concept is text vectorization. Here we have a graphical representation of this concept, that basically we have a text. Once we have created those smaller chunks, smaller pieces of text, we need to pass all of this data, all of these different pieces of text through an embedding model, and we will be obtaining these vector embeddings, okay? And why this concept is important? It's important because these embeddings, they will capture semantic information and also syntactic meaning of these tokens, and it will enable tasks like similarity search and other advanced analytics. And here it's a table that contains basically the text and also their correspondent vectors. Now we'll be discussing a case study. And here we need to imagine that we have this car dealership company, we have different car models with their corresponding descriptions, and we don't want just only to store the data in an efficient way. We also want to perform advanced searches based on semantic descriptions or features. We want also to enhance our ability to match these customers with their ideal cars. So graphically, it will be the following process. We have different documents. We are performing this manual chunking using library Python and some Python libraries, and then we will be creating this vector embeddings using different text embedding models, and we will be obtaining this data frame, this table, with the following fields: the ID, the title, which basically are the different car models, the corresponding description, which is this text of field, and the vectors, okay, of those texts. And all of this data will be stored in Azure AI Search. Now, talking about the database configuration, we will need to go to Microsoft Azure portal and to the marketplace. We'll be searching Azure AI Search, and you will be creating the search service. You just need to enter the subscription, the resource group, also the name that you want your search service to have, and the location and the pricing tier. Within the pricing tier, by default, you will be having this standard one, but you are able to change it. In fact, this is what we have done. We have selected the basic configuration, okay? Because we are just in an environment development environment, in a test environment, sorry. And going on, we have here, right, we need to review the configuration that we have made with the pricing tier, also estimated cost per month, which is 70.34 euros. And we have here also an URL that will allow us to connect to Azure AI Search and perform some operations. Now, talking about Azure OpenAI, basically, this is just the partnership between Microsoft Azure and OpenAI, and it offers tools like for creating vector embeddings and also for using large language models and so on. You have this Azure OpenAI service that enables semantic similarity searches across different Azure vector databases, and all of these models are accessible using this Azure OpenAI service, and also you have different ways in order to access all of these tools, such as using REST APIs, using Python, and using also Azure OpenAI Studio. And at the end, Azure OpenAI is focused on secure and responsible AI usage. There are different models, different embedding models that we'll be explaining, such as the text embedding 3 small, text embedding 3 large, and text embedding ADA002. Talking about the first one, the text embedding 3 small model, basically this is a high efficient and cost-effective embedding model that outperforms the predecessor, that was the text embedding ADA002, and it works better while working with multi-language retrieval and also for English tasks. And it has a 5 times reduction the price of this text embedding ADA002 model. Basically, we can see here the function, okay, the function that will allow us to create these embeddings, will allow us to vectorize all of our text data, okay, and we need to take into account that we need to connect to this client, okay, and we have here the embeddings create methods that will allow us to do that. And in terms of timing, okay, the operation of creating the embeddings took 113 seconds. This is the output that we are getting. Okay, here we have all of these text in a vectorized way, and the dimensions of the vectors is 1536. Moving on with the next one, the text embedding 3 large model. Basically, this is a high dimensional embedding model that significantly outperforms other previous models. Okay, it offers 3072 dimension vectors. Okay, and it is priced at $0.00013 per 1K tokens, and within different benchmarks such as the one from Hugging Face, it is really in a good position there, okay, and it makes it ideal for high accuracy applications. Again, we will be using the same Python function, and in terms of the time, okay, timing, this embedding function took 122 seconds. Here is the resultant data frame that we've got with the vector dimensions of 3072. Now, talking about the text embedding ADA002 model, this model, okay, basically replaces other models for text search, text similarity, and other operations. It is really good in performance, and also the cost is not so high, and it generates 1532 dimensions embeddings, and it enhances tasks like document processing and other complex search applications. We will be using the same Python function that we have explained in the previous models. And in terms of timing, this embedding function took 118 seconds. This is the resultant data frame that we've got with the dimensions, with the vector dimensions being 1536. And the consideration here is that all of these different text embedding models from Azure OpenAI have some vector dimensions by default, but using this other function here, this normalize L2, we are able to change, to reduce, in this case, these embedding dimensions. Why this is important? Because basically using larger embeddings, okay, it makes us, okay, to increase the cost in terms of the cost in terms of costs. They incur in higher costs that at the end consume, and also they consume more compute, more memory, and also more storage, right? That rather just using smaller embeddings. These are just the embeddings cost estimation, okay, for the different models here. For the text embedding 3 small, it costs 0.0005. The text embedding 3 large model, it took it has an estimation of 0.002. Also, the text embedding at 0.002, it has this estimated price. Now, talking about the Hugging Face, basically Hugging Face is a collaborative platform that hosts over 305,000 machine learning models, also 75,000 datasets, enable users to share, explore, and build open source models in a collaborative way. We have this massive text embedding benchmark, okay, and within it, we have chosen several models like these ones, okay, all mini LML6 version 2, the Voyage Large 2, also the Cohere Embedded for English version 3. Then the first embedding model, the all mini LM L6 version 2 model, basically it uses this sentence transformers library, and it is designed to convert the sentences into 384 dimensional vectors, and it works really good for tasks like semantic search and also clustering. It is based on the mini LM architecture, and it is optimized for speed and lower resource use while maintaining high performance. This is the function that we have been using. Okay, we have here the sentence transformer library method that we will be using. This method also encode that will actually convert those those texts into vector embeddings, and the embedding operation took 14 seconds, which was it was faster than the previous embedding models from Azure OpenAI. This is the resultant table, and we can see here that all of the vectors have a size, a dimension of 384. Now, the second model, the Voyage Large 2 model, basically, this is a high-quality text embedding model from Voyage AI, and is capable of processing up to 16,000 tokens with an embedding dimension of 1,536. It excels in generating embeddings for large documents, and it is optimized for trivial tasks, and that they are accessible using Python API with the corresponding required API key, okay? This is the function that we are using. We need to pass here the API key that we will be needing to use in order to connect to and use the model, okay? And an important also thing here is that we have this inner function, okay, and this model, it only allow us to compute these embeddings, okay, for batches that have the size of 138. 28. That's why we have this inner function that basically what it is doing is making sure that all of the text, it's not over, it has not a batch size over 128, okay? Then in terms of times, it took 11, almost 12 seconds. That means that was super fast also. And also, as before, we've got this data frame as an output. Then talking about this Cohere Embed English version 3 model, this is a text embedding that is designed for semantic search and other AI applications. It supports over 100 languages, and it is optimized for handling complex datasets. It is accessible via Cohere API, also Amazon Web Services or other private endpoints, and it offers a versatile tool for various businesses and research purposes. Here is the function that we'll be using. We need also, again, an API key in order to connect and be using this model, okay? And here the input type is this search document, and we are just converting also the embeddings in a NumPy array data type, okay? And then this embedding model took almost 7 seconds. This is the output that we've got once we've embedded our documents, our texts. And now a comparison between OpenAI and Hugging Face. Basically here the important concepts is that the vector dimensions that all of these embedding models offer to us, okay? And of course the pricing also. And we need to consider that here this model, for example, the All Mini LM L6 version 2 outputs vector dimensions of 384, and then the text embedding 3 large, it outputs vector dimensions of 3072. So this is a really interesting table, and when all of these different things are we need to consider them, okay, in order to choose one embedding model or other. Now talking about Azure AI Search, basically here, once we have configured our Azure AI Search vector database, we need to create the index, okay, and also to upload the data. Basically, upload is to do the data ingestion process, right? And basically, index in this context is a structured format for storing, organizing, and searching documents, and is similar to how a regular table organizes records. Okay, each index contains a collection of documents that conform to define schema, that data schema. This includes fields such as names, data types, attributes, and so on. And these attributes at the end determine how the data within the fields can be used during search operations, such as whether the field is searchable, filterable, sortable, and so on. Okay, this is a really important concept. And we have different configuration here that we need to explain and go further, right? We have here this search index that contains within itself different configurations for the field, okay, and also for the vector search or the semantic search. We have a super useful method, which is this one, create or update index, which will basically allow us to create or update the index that we'll be using to perform to upload all of the data, to perform all of the vector searches, the semantic searches, and so on. And also we have here another method, which is upload documents, which will allow us to do this data ingestion process to populate Azure AI Search, basically. Now talking about the first configuration for the fields, okay, here we need to take into account different options that are basically this simple field, this searchable field, or search field. Search field is a field in data type, okay, that is suitable for storing vector embeddings. That's what we are using it, okay, in order to define our vector field as a search field. And in terms of searchability, okay, the simple field is non-searchable by default, but it can be used in order for filtering purposes, to create facets, and so on. The searchable field is searchable, as its own word implies, okay, and it is also retrievable, and it's intended for full text searches. And finally, here the search field is full text searchable, okay, and it has different types within itself. Okay. For storing the vector embeddings, we'll be using this collection search field data type single. Another important thing is that the simple field data type, it's used usually or it's ideal for ID fields. That is the one that will be used for filtering, sorting, and so on. The searchable fields basically are suitable for fields such as the title and the text that actually contain the information and the text or the titles where that we will be accessing those fields to retrieve the information and to perform those text searches, right? Then the search field, as I said, is for to store the vector embeddings. Now, talking about the vector search configuration, here we need to take into account that for this case study, we are using the algorithm kind that we are using is this hierarchical navigable small world, which basically is an approximate nearest neighbor algorithm. Also, we need to take into account other parameters, okay, such as within this kind of algorithm, okay, such as M, which is basically this bidirectional link count that ranges from 4 to 10. And here, lower values reduce noise in the results, okay? Other important parameters are this EF construction that ranges from 100 to 1000, and this is the number of nearest neighbors used during the indexing process, okay? And this parameter affects the speeds and quality of the indexing process. Then we have also the EF search, which also ranges from 100 to 1000, and this is the number of nearest neighbors used during the search process. And this parameter affects both the speed and quality for the vectors, the search the process that we will be computing. The metric will be the cosine similarity, and the name is a unique name for the vector index. And for the vector index, not for the vector search process. And within the profiles parameters, here we need to just enter the configuration name of the vector, okay? And the second one is for the configuration name for the algorithm that we'll be using. Now, talking about the semantic search configuration, here basically this configuration uses advanced language models to understand and improve the relevance of the search results by interpreting the intent and also the context of the different queries that we'll be making, right? There are different options. The title file field will contain the field that has the title of our documents, and also the content fields have the field that contains actually the content, the text that will be analyzed semantically, okay, as we will be explaining in the next slides. Here, the vector search process, basically the principal concept here is that first, we will be doing a query. We need to obtain or to vectorize it in order to extract and to get these vector embeddings. Then we are just retrieving the key nearest neighbors equal to 3, which means the top 3 results. And this is the name of the field, okay, that contains our vector embeddings within our Azure AI search database. We are using this, we are connecting to the search client and we are performing this search, okay? And here there are several parameters that also we need to take into consideration. Here the search text is known because we are just performing a raw vector search, okay? The vector queries is the vector query that we have defined previously, and also within the select parameter, we are just specifying the name of the fields within our data table that we will be outputting, okay? Now, there are different scenarios for vector search, and these are the vector search that we have explained, okay? But also this hybrid search, and the only difference is that here we are not only doing the search using these vectorized queries, but we are using also the query as it is, okay? The sentence itself. Then we have also other options that are super interesting to consider, okay, which are these semantic search capabilities. And here we need to go to the search service within the settings, the semantic ranker, and we need to be sure that we have selected a plan. Otherwise, we won't be able to perform any semantic search, okay? And the important things here is that the semantic hybrid search, basically, it will not only perform an hybrid vector search, but with these two parameters here, the query caption and query answer, will be able to also use the semantic capability to enhance our results, the answers that we will be getting, right? We are using these extractive methods for both of them. And for the first one, for the query caption, basically, this indicates that the search should attempt to extract the captions, the summaries, basically, from the documents that match the query, okay? And these captions provide us context relevant snips related to the query, okay? And this enhances our search experience. And in the second case, this query answer, also the method is extractive, and this specifies that the search should also try to extract direct answers, okay, to the query from the documents that we have. And this should be useful, okay, for queries that, for example, are phrased as a question, because at the end, a concise answer will be needed, and we will be able to extract this concise answer using this extractive method. Then we have also the semantic search a scenario where we will just be performing a semantic search. Here we have the query type as semantic, okay, and we will be passing the search text, which is basically the query in the sentence format as it is, okay. And also, again, as before, we have here the query caption as extractive, and top 3 is just to obtain the top 3 results. Now, okay, basically, we have here the different options in order to do the search queries, okay, and the important things here is that the vector search, it uses embeddings to find these conceptually similar documents. Then this hybrid search combines the vector search but also the keyword search, okay, and it has a broader applicability. Then the semantic hybrid search, it enhances the hybrid search with this semantic ranking capability, okay, for better relevance. And also the semantic search, it focuses on query intent and contextual meaning. And as I said, indexes are super important within this vector database, because they are used to enable these full text search capabilities across contents from different data sources, and it makes easier to build these rich experiences, search experiences, over this large, huge amount of data sets and so on. In terms of cost, taking into account that the database configuration is the basic SQUB, is this price per month, okay, and we are just utilizing one search unit out of 3 that we have as an option, and the results that we are obtaining are basically the following ones, okay. Using these embedding models, the ones that we have been explaining, okay, the index creation took for the text embedding to small 1.67 seconds. Then the same as the text embedding through large, but the text embedding ADA 002, it took less, 1.62. The all mini LM L6 version 2, it took almost 2 seconds. The Voyage Large 2, it took 1.62. And the Coherent Embedded English version 3, it was the fastest one. Talking about the index creation, it was 1.46. And in terms of the data ingestion process, when we are uploading our data into Azure AI Search, here we have the different timings, okay? And this is just the different the different characteristics, okay, of the embedding models, right? The vector dimensions that they have, also the maximum number of tokens that they allow to work with. And now, talking about the text embedding through small model results, here are the different queries that we have been making, okay? Which car model is the safest one or has more safety features? I want to buy an electric vehicle, suggest a car model that has a great performance and a powerful motor. I'm going on an adventure and I need a car. Recommend me 4x4 vehicles for a comfortable ride. And we can see the different timings, okay, while performing these vector search queries, okay? And these are the results that we have obtained, okay, with the similarities, here, okay? Then again, for the text embedding through large model, okay, we can see that it took a bit, it took 0.66 seconds for the first query, then it was faster for the following queries. Then also for the text embedding at a 002 model. I'm not explaining this because after we will be also seeing this in a more visual way, okay, within a comparative table, okay. But I just wanted also to see that to say that the similarities here are different, okay, and this is also quite important. And for the all mini LM S6 version 2 model, we've obtained also different similarities and also different car models and so on. Okay, for all of the queries and all of the tests that we have been doing, also for the Voyage Large 2 model. These are the results obtained. Also for the Coherent Embed English version 3 model. Okay. We can see the different similarity metrics, also the different CAD models that we've retrieved as an answer. And this is the comparative table that I was talking about. And basically, we can see here important things is that we have the different queries here, okay, the different embedding models, and the averages of these cosine similarity metrics, and also how much they took in order to perform these vector searches. And basically here we can see that in terms of average cosine similarity, the one with higher results was the Voyage Large 2 model. And in terms of the vector search process, okay, how much the process took, or the query, the vector search query took, the fastest one was the text embedding at a 002 model. Next steps here, visually or graphically, we can see here that we have the different documents, okay? We can be using a strategy method or either the line change framework, either doing it manually as we've done. Then we will be creating the vector embeddings using OpenAI API. We'll be storing all of this data within a vector database, Azure AI Search in our case. We will be performing this vector search, okay, query, and we will be obtaining this information, these different car models with their corresponding descriptions and the corresponding vectors, and also the cosine similarity metric. And we will be passing all of this retrieved data, retrieved information through, again, OpenAI API, but in this time we will be using a large language model, like for example in ChatGPT 3.5, and we will be able to enhance our answer and to visually obtain a more a better answer. Okay, so in this case we are asking, I am going on an adventure and I need a car. recommend me 4x4 vehicles for a comfortable ride, and we are obtaining here a better answer rather than just a table, okay, that at the end we need to interpret it and so on. Okay, talking about the conclusions. Here, some observations that we've extracted from the results, okay, that we have been talking about. The first observation is that the text embedding through a small model shows a moderate similarity scores around 0.67, and the text embedding through large has a slightly higher scores, and this indicates a better capture of similarity. Also here, the text embedding ADA 002 model shows significantly higher similarity scores, with the top score close to 0.87, suggesting a very strong similarity with the chosen document. Also here, as we said, the last embedding model, the Cohere model, was even higher, right? So this means that the similarity is strongest, okay, with the chosen document. And an important also observation is that these car models, the Kia Sportage, Kia EV6, and Nissan Rogue are a common top result across all of the models, okay? And this means just that the results that we are obtaining are consistent in relevance to the queries that we have been making, okay? And these varying scores between models highlight also the importance and the relevance of the choice of the embedding model that we will be using. Okay, there are several factors that are important in order to choose one embedding model or other one. Okay, so these are different factors or different considerations that you need to take into account in order to choose one text embedding model or other. And these are, for example, the model dimensions. And different models have a varying embedding dimensions, which at the end affects in the creation of the embeddings and their subsequent utility. Also the chunk size, okay? We need to find a balance between these chunk sizes in order to be some kind, to find homogeneous pieces of text, okay, more or less of the same length, to be able and to be sure that the context is preserved, okay, and this is crucial, okay, for maintaining this semantic integrity. And then also we need to take into account the performance needs, the hardware capabilities, the privacy concerns, the ease of use, if we count with an already API to use, and also the costs, okay, are important. Here we can see that the Voyage Large 2 model is priced at 0.00012 per 1 million tokens, okay, but for the 50 million tokens, the first 50 million tokens is free, so this is pretty convenient. Also, we need to take into account that the Cohere Embed English version 3 is free for development purposes, okay, it doesn't cost anything, but if you want to go into production, you need to pay $0.10 per 1 million tokens, okay. Then the text embedding 3 small is $0.02 per 1 million tokens. The text embedding 3 large is $0.13 per 1 million tokens. The text embedding ADA 002 version 2 is 0.10 per 1 million tokens. And finally, we have this all mini LM L6 version 2, which is free. These are the references that I've been using in order to create this session. And thank you again, all of you, for being here today with me. And also thank you to Global AI Bootcamp 2024 for counting with me as a speaker.